Okay, good afternoon, guys. We are going to get started. Sorry, we're a little bit late here. We had to let the students head downstairs to the workshop. So you're here for the advisor training. It's relatively short. It takes about no more than about 30 minutes, and then we do a Q&A, which last week actually lasted for about another 30 minutes. So we had some great questions last week. So by way of introduction, my name is Kevin O'Loughlin. I'm one of the lead judges here, along with these other guys in the black shirts. And thank you for signing up to be an advisor for the students. Because you guys are doing this, it enables the students to participate in the Tech Challenge, which is the best thing for everyone. Please read the website. There's a bunch of information on the website. The rules, the FAQs, which will be populated this weekend. There's a lot of information on there, and we just touch on it during these sessions here today. So please encourage your students to read the website, and I encourage you advisors to also read the website. And check back every so often, because the FAQs definitely are updated. And believe it or not, even the rules were updated at least once. The rule changes were flagged in red in the rule package. Because as we discover new items, we sometimes have to slightly modify the rules. Nothing dramatic, but you'll see what's on the website already. So how many former advisors in the room? Okay, one person, very good. How many of you advisors have an engineering or technical background? Okay, well, the good news is, to everyone, is that you do not need to have a technical background or engineering experience to be a good advisor. It's kind of a common sense position. You're the driver, you provide the transportation to the students to get from point A to point B. You assist them with the purchases. You guys have the wallets. Sometimes you open up your homes to enable a meeting place for the teams, or drive them to their community center or the school. And quite frankly, you guys are the adults in the room. Sometimes you're the referee if the students tend to perhaps getting into an argument with each other. Perhaps one of the most important jobs for the advisors is to feed the teams and keep them happy. The bottom line is be a facilitator and be a mentor for the teams. Encourage them and don't let them give up. That's the negative in starting a challenge that takes place over several weeks. And we started this back in October. Some teams started back then. The Tech Challenge is not until the middle of April, so the students could possibly get discouraged and not want to continue. So your job, advisors, is to keep the students encouraged so that they show up on the day of the event. All right, so if you attended the info clinic this morning, you saw a lot of this already, the actual challenge. Design a device that will use the wind energy of the fan to move the water from the reservoir into a receiving tank. Receiving tanks are different sizes depending on whether it's 5th or 6th grade level. That's the 1 liter tank. It's 6 inches high, 5 inches? 6 inches high, and you have to move 1 liter into that tank. And 1 liter in that tank is actually a very small amount. There'll be a dummy tank inside to allow the 1 liter to look larger for showmanship. If you're an advisor of a high school student, they have a little bit larger challenge. They have to move 3 liters of water into a taller tank. So that's the challenge, using the energy of the fan only. It has to be done in 3 minutes or less, as Steve described this morning. And as you saw the video, this is a lot of fun to do this. Believe me when I tell you that your students will have a blast if they come to the Tech Challenge Day. They will have a lot of fun, and you'll have fun too, and it's open for family and friends as well. There'll be bleachers set up, and the adults can sit there and watch the teams participate. They'll actually also, the tech does a great job in the audio-visual. There'll be a large screen video display above each rig, and there'll be cameras on these students as they go through their challenge, and so the audience will have a big screen to take a look at. It's actually very well done. All right, so advisors. I'm an engineer. I'm also a former advisor when my daughter did the Tech Challenge back in 1997, and I'm going to freely admit that I helped too much. So I'm going to challenge you guys to not make the same mistake I did. Do not, hands off their project. Don't do it for them, except for safety, and we're going to talk about that. Encourage the students to do it themselves. Don't do the work for them. They will learn more from doing it themselves and not doing it as well as you guys may be able to do it, because you guys may have some fantastic ideas. They'll learn more by doing it themselves than if you guys do it for them. So help them to do it themselves. And we're going to talk about power tools for a second. You guys are the adults in the room. We want you guys to enforce safety. We mentioned it this morning. We're going to mention it again. We don't expect any fifth grader to operate some serious power tools like a table saw. You guys know the abilities of your students. If you don't think they can do it, the tech does not expect a student to operate some serious power tools. That's not violating your contract about not doing the project for them. They should tell you where to make the cut. They should give you the measurement. They should draw the line. You guys can actually operate the table saw if you're trying to cut something like that. Even if it's incorrect, you may not want to waste a piece of wood, so you may want to ask them, are you sure this is where you want it cut? But please don't build it for them. And we mentioned this morning the aspect about safety and water and AC power, and Steve's holding up the ground fault circuit interrupter. It's a very important part of testing at home or testing here during the actual Tech Challenge. During the Tech Challenge, the tech will have a GFCI interrupting the power for every single rig. So if you guys are testing this at home, if you're building some sort of a prototype test device, please do this at home. We want to make sure that water and electricity are kept separate. All right. You guys should be supervising the testing whenever they're using the fan with the water tank at home. You guys should be aware that they're doing it. There's water in the tanks. It can get slippery. Puddles of water can fall on the floor, so you guys should supervise their testing. We also mentioned this morning that teams are encouraged to identify a safety officer. And as judges, we're going to ask the teams right off the bat, who's your safety officer? We'll do this during the test trials, and we'll do it during the challenge day. So as advisors, you guys should be encouraging the students to set up a safety officer. And the duties of the safety officer are to monitor the team for safety, make sure everyone's ready to begin, make sure everyone's ready to move, lift, and so forth. We mentioned this morning also about all teams should be wearing ANSI-approved eye protection. The teams have to provide their own eye protection, so you guys will have to provide those for the students. And quite frankly, the teams without eye protection, if they show up in the day of the challenge, they won't be allowed to compete. No flammable liquids, no high-pressure gases. It's explained this morning and also on the website. And do not expect to have AC power for your device. It will not be available during challenge day, and during the test trials, there's no guarantee. So if you're going to bring some tools to work on, your device, if the students are going to bring some tools to work on their device during the trials, and we see this very, very common, students will test their device on the rig during the trials. Something doesn't work, they go off, they're going to make a change of their device, and they're going to come back. So we frequently see them, in this room, we frequently see them using some tools to make modifications of their device. Those should probably be battery-operated tools, only because there's no guarantee they're going to have an outlet here at the Tech. All right, here's our graphic about the eye protection. Got a few slides here about shop safety. I went online and found some information about shop safety, came up with about 3 or 4 slides. Some of the stuff is common sense. It may seem ridiculous to talk about it, but we're going to present it anyway, and you should enforce this at home. So besides eye protection, if you have long hair, make sure you have your students tie that hair out of the way. And the example I like to mention is my own daughter she was an architecture student down at Cal Poly, and they operate power tools down there. They're checked out on them before they're allowed to use them. And they go through, not a certification, but they're checked out on the tools. And they go through all these things about eye protection and tying their hair out of the way. So my daughter has long hair, and she knows better. She came home during the summer, and she was out in the garage, and she was using my Dremel tool. Anyone know what a Dremel tool is? It's a single shaft rotary device you can use for sanding and grinding. So she knows all these shop safety rules, and yet after about an hour of being in the garage, she came in the house and she had the Dremel was stuck in her hair. So even though she knows that she shouldn't do it, she didn't do it, and she had to face the consequences. We had to make a small little cut to remove the Dremel tangled in the hair. Not a big deal, but so please, if you see your students with long hair, encourage them to tie it back. If they're wearing loose clothing with really loose sleeves, they should be rolled up to get it out of the way. Ear protection if it's a very loud power tool. Please use the right tool for the job. This might be a good time to introduce your students to the owner's manual for the tool. You can dig those out and make them available for the students. Make sure that the bits that the students are using are the right bits for the job. So what we mean by that is, if they're cutting wood, make sure it's a wood cutting bit, a bit designed to cut through wood. And also for metal, if they're going to cut through metal, make sure that the bit or blade that they're using is designed to cut through metal. Always use the right tool for the job. And I'm guilty myself of using a stapler sometimes to hammer a nail or a tack. Don't do that. Use a hammer if you're going to do some hammering of nails. We have some pictures here, and there's actually a violation of the safety rules on this slide. Does anyone see what's wrong here? Go ahead. Yeah. There's no guard on the saw blade there. So we actually have this, the rule on the next slide, but yeah, this is a violation here. Every table saw should have a guard over the blade. So I'm going to say that the guard was lifted up to facilitate taking the picture here. So have a clean work environment, no clutter. It doesn't mean that everything has to be spotless, but if they're using power tools, there shouldn't be a bunch of stuff under their feet. Make sure the guards are in place. They're there for a reason. Make sure they have adequate lighting. If they're working on a bench here doing something, they shouldn't have a light behind them so that their head casts a shadow on their work. The light should be appropriately placed. So, bottom line is shop safety is a life lesson, and doing this for the Tech Challenge is a good introduction to the students for the rest of their life. All right, so let's talk about facilitating conversations and how you might address the students when they ask you a question. We tell you not to give them the answers. We want you to facilitate having the students do their own investigation. So we ask you to use open-ended questions. So what is an open-ended question? Well, a closed-ended question is something that requires a yes-no answer. It's very, very short. So the example is, do you get on well with your boss? It's kind of a yes-no question that expects a yes-no answer. So an open-ended question along those same lines might be, well, tell me about your relationship with your boss. That question kind of necessitates a little bit of dialogue. Oh, that just got spooky. Well, I'm just going to keep going here. Who will you vote for in the next election? It's kind of an A or B answer, right? Versus the open-ended question would be, well, tell me about what you think about the two candidates in the election. So you can kind of see the difference between a closed-ended question and an open-ended question. So how do we tie that to Tech Challenge? Well, the students may ask you, what do you think we should do? Instead of telling them what you think they should do, you should kind of turn that around and say, well, what do you think you should do? If the students say, what direction should we take to solve the challenge, you should turn that around and say, what are some of the pros and cons of each of the ideas that you have, and which idea has the best chance of succeeding? And they should be documenting all of this information in their engineering journal. Students might say, will this idea work? And you would turn that around and say, well, how could you test that idea to see if it's going to work? So please use open-ended questions to get the students to kind of do their own thinking and come up with their own answers. This is an interesting topic, equity in engagement. I actually found this on the Tech website. And what we mean by that is you may have a team of, well, let's say you've got 5 students on the team, and maybe 2 students know each other really well, and maybe they're kind of dominating the team, taking over the team to the detriment of the other 3 team members, and they're leaving the other team members' voices unheard. So you guys are the adults in the room. We ask you to be on the lookout for that and make sure it doesn't happen. So if you see some team members kind of dominating and making decisions, you might ask the team, have you all taken a vote on that decision, on that way forward, on that type of material, to make sure everyone gets a chance to participate. Now, we're not saying that having a group team leader is not unexpected. That's just natural, that you might have one person who's kind of the team lead, but we don't want anyone to kind of walk away with the whole challenge and leave the other people left out. So you guys should be encouraging the team to test their ideas. They're going to have multiple ideas, and as I said this morning, the first idea they come up with almost guaranteed won't work. So they need to test the idea. Test, modify, retest. Test, evaluate, modify, retest. So during the test trials, we're going to have one of the exact rigs that you're going to have available during the day of the event. We'll have the exact rigs here at the museum for the students to come and test on. But you don't have to wait for that. You can actually test at home, and we give you all the dimensions for the rig. But the Tech doesn't expect any adult to build a rig like this to this level of detail. As was mentioned this morning, this very simple mock-up here using some cinder blocks and some wood scraps and a 5-gallon bucket, this would go a long way to test the students' ideas. So simple rig at home with using the GFCI outlet, which you can see in the background there. And then please come to the test trials right here at the museum starting the last week of February. And remember, the device performance, or actually solving the challenge of moving the water from the reservoir to the tank, is really only about one of the 3 areas that the students are going to be evaluated in. They'll also be evaluated on their written documentation in their journal, as well as the interview where they're familiar with the engineering process. All right, speaking of the journal, each team must have an engineering journal. Do not write the journal for the students. You guys should be encouraging them to document their own journal. So for example, today they attended an info clinic this morning. That should be in their journal. they're attending a workshop right now, that should be documented in their journal. What did they do? What did they learn? What are they going to go forward with? So you guys should be encouraging them to document stuff like this. If they have a team meeting in your house, encourage them to document that. And as I mentioned this morning, all of the information that the tech is expecting to be in the journal, it's all on the website. Handwritten journal is absolutely fine. A word process report, absolutely fine. Science fair board, not an alternative to a journal. And some of the 5th and 6th graders are used to science fairs, and they're used to these trifold boards that you come up with for science fairs. That is not a substitute for a journal. If they want to have one of those science fair boards to help facilitate presenting their project to the judges, they can certainly do that. It's not required, though. All right, teamwork. Definitely important engineering skill, an important life skill. So the judges are going to be looking for this. During the actual device performance, the judges are going to be looking for how the team performs well together. Do they all have a job to do? Are they operating like clockwork? That's what the teams are going to be, that's what the judges are going to be looking for. If they're bickering, if they're kind of stumbling over each other, that shows poor teamwork, and they'll be scored down for that. So, advisors, you should be encouraging, does everyone have a role? And has the team taken advantage of everyone's roles? So everyone has different skills. Maybe someone is better at drawing the sketches in the journal. Maybe someone's a good photographer. Maybe someone's the best person to document in the journal. Maybe someone's the best person using the power tools. Maybe someone's the best spokesperson for the team to be the team leader. It's teamwork. You guys should encourage the students to look out for the skills within the team and to make best use of those strengths and talents. Okay, presentation. Technical people need to be very good at communicating. This is a reality. So during the Tech Challenge Day, the students will be interviewed by the judges. And one of the questions I, as a judge, would be asking the 3-person team, I'm going to ask every single person what their job is. I'm going to go down the line. I'm going to ask every single person. So my first question might be, tell me about your device. And maybe the team leader, if there is one, makes that presentation. But I'm going to make sure as a judge, I ask every single person on that team, what did they do to contribute to this device? And hopefully they'll have an answer. We're looking for them to present their ideas clearly, show off their team spirit. If they have a costume, that's fantastic. So what can you guys do as the judges? I've already told you there's going to be an interview. I've told you some of the questions that the judges are going to ask. You guys can play the role of the judges and interview the team ahead of the Tech Challenge Day. So you can sit down and have the teams present their device to you. And first question you're going to say is, tell me about your device. They should be able to clearly explain their device, how it works, what other ideas they tried, what role each of the team members had. So that's your job as the advisors for presentation. All right, next to last slide here. Some miscellaneous items here. Keep safety in mind. You guys are the adults in the room. If it looks unsafe to you, it's probably unsafe. So stop it. Stop what they're doing. Whether it's in putting together their device, it's in using a power tool, in moving devices from one room to another. This is where we see a lot of the klutz factor happen. Some students picking up perhaps a big length of pipe, and a student picks it up from the middle, and then they hold it to their shoulder, and they've got it sticking out in the front and back, and then they turn and rotate and hit someone in the head, the Three Stooges. What we'd like to see as judges is, as a team moves something like that from point A to point B, is that there's someone at the front and someone at the back, and they're moving it as a team. So look out for that. That's just a heads up. Can there be more than one advisor per team? No. No, we want only one advisor per team. What's the reason for that? Well, too many adults get in the way. And I'll tell you a story on this. We had a team, I think it's 3 years ago, and Dad was an engineer, Mom was an engineer, and their aunt and uncle were also engineers. So they had 4 adult engineers, technical backgrounds, perhaps helping a little too much. And the students at that time, they actually won an award. They came back the following year, and they signed up for Tech Challenge, and they told their adult advisors, they said, Mom and Dad, no help this time. We want to do it ourselves. They didn't win anything that second year, but they told the judges that they enjoyed the second year more than the first year. So heads up to you guys. One advisor per team, let them do the task. Can one advisor coach more than one team? Absolutely. There's no problem with that. As long as you don't spread yourself too thin, there's no problem whatsoever. And as we mentioned this morning, you can't be a judge and an advisor in the same year. It's kind of a conflict of interest. As a judge, you get to know the exact scoring rubrics, so you can't do that and be an advisor the same year. And also, if you're a parent of a student within Tech Challenge, for the current year, you also cannot be a judge for the same reason. All right, so my last slide. So thanks again for signing up, taking the time out of your busy day to come here to the Tech, bringing the students here for the info clinic, allowing them to attend the workshop, and to sit down here and hear some of the advisor information. Thanks for encouraging the students, and do not let them give up. The middle of April seems like a long time away, but it'll be here before they know it, and we want to see everyone participate. Remember, even if they have a device that is not going to necessarily work on the day, they should come anyway. The engineering process is one potential score and award. Engineering Journal, one potential score and award. And they will have so much fun just showing up, as you will also. So I encourage everyone to show up on the day of Tech Challenge. It is a blast, as you saw on the video. And with that, I'll open it up for questions. Yes, sir.
I just want to add one thing. Just regular glasses are not the eye protection. I mean, they do not count as ANSI protection. Most of the ANSI protection are going to be goggles or glasses with side shields or something. So you need to look at that. There are items, if your students wear regular eye protection or regular eye glasses, you can get the goggles that easily fit over them. But just regular glasses do not count towards this eye protection.
And along the same lines, neither do ski goggles or scuba goggles. They are definitely not ANSI approved. They're not shatter resistant, I know from experience.
All right, so questions, anyone?
Raise your hand, I got the mic right here, I'll bring it to you. So.
Hi, I was just wondering if this presentation and the one from earlier this morning are available online.
I'm told that, yes, we're being videotaped today, so it should be available at some point. Yeah. No guarantees, but that's the plan.
Yeah, everything's on the website. We tried recording last week, but had audio problems. So this week, hopefully, because this is the last weekend, hopefully we've got the audio situation all figured out.
Anything else? Yes, ma'am.
Where are we, sorry? Okay.
Can you tell us a little bit about technical support for the team, given that some of us or a number of us don't have the technical background in electrical engineering and other things we might use for developing this rig? What sort of support do you guys provide or recommend?
Go ahead, Jerry. You have an answer?
Well, so if you sign up for team registration, there's a question in there that says, would you potentially like a mentor? And if you check that box, there's no official process here, but We do have volunteers from the who's who of Silicon Valley companies who have been interested in mentoring a team. So they've expressed their interest to us. Teams have expressed an interest in being mentored. The Tech Museum, the plan is basically we'll connect mentors with mentees via email. But the Tech Museum itself, for liability reasons, is not formally this year doing any mentoring program.
So I would say that's a very non-committal. So what I would say is Google, this problem is not necessarily, the Tech Challenge 2014 is not necessarily out there specifically, but there's an amazing amount of information out there online in YouTube about moving water and using wind power. Google is an amazing resource out there. You guys should not be doing the Googling and looking for these resources for them, but you can certainly ask them, have they Googled some keywords, wind power, moving water, and there's an amazing amount of information out there for even the non-technical person to get some great first ideas.
Yeah, my recommendations generally for YouTube would be minute physics, as in the minutes and length of time physics, head squeeze, and of course in general Khan Academy, which is start off with math principally, but is branching out to the sciences and physics as well. So those would be some recommendations for places to go and learn some concepts.
Any other questions? Yes,
Oh.
sir.
The question is, our team is, one is 6th grader and 2 5th grader. So I don't think so they will be using Power Tool, but is it okay as an advisor? Of course, as you mentioned, they should tell me the measurement and I will cut. But even like creating the base and all that, do you think I should help or I should not?
Making the test rig?
Not the test rig.
The device.
In fact, the device, because ultimately the device will stand on some base, right? Because otherwise it will fall, right? There. So
The students should be doing all the construction themselves. I mean, I expect even a 5th grader to be able to use a drill and screws and everything.
Oh.
So you might make the cut on a table saw, but then give them the resulting pieces of wood. They should be able to put it together.
okay, good to know.
If it's a critical cut with a real sharp rotating blade and you're not comfortable with them doing that, by all means you make that cut, but then give them the pieces to put together.
Sure. Okay.
And I'll give you another war story about a prior year device that we saw. It was the same year, 2007, I think, there was another water moving device using the power of water to move water to a higher tank. And this rig that came in was a beautifully like a bookcase made out of plywood. And it had beautiful 90-degree corners and triangular pieces for reinforcing the corners. And this thing was beautiful. And I do woodworking, and so I asked the students, I said, wow, this is pretty nicely done here. Who made the cuts here? And I said, well, who put this thing together? And they said, we did. And I said, well, who cut this out? And they said, well, Dad did this. I said, okay, who cut these triangular pieces? Well, Dad did this. And who cut out the circles in there to save weight? And they said, well, Dad did this. And this was not a 5th grade team, but it was obvious to me that Dad built this whole thing. So we don't want to see, we expect, if we see a 5th or 6th grade project, we know what 5th and 6th grade work looks like, and if it looks too good, we're going to ask a lot of questions.
Okay, thank you.
Anything else?
Hi, thank you for all this. I was wondering, my students, they missed this morning workshop and whatever was going on, so they have no chance to write it in a journal. Will it still be okay?
Oh yeah, you write in the document in the journal any experience that the students have, whether it starts with reading the website or going to OSH for getting some parts or come to a workshop or info clinic, whatever. Yeah, and if they review, like if this video is available or this morning's video is available later on online. If they look at it online, they should document that in the journal as well. Yes, ma'am. Finally, we'll get to you.
Yeah. Hi, I'm just wondering if you may share, when they come here to test their device, it's a 2-hour slot. So I'm wondering how that works. Like, do they test it, have it fail, work on it again, and are they able to test it again?
They can test it once or as many times a day as we can get to them. So there'll be a whiteboard. I think Richard explained this morning, there'll be a whiteboard for them to sign up. They show up for the 2-hour slot, show up early. We're going to put their team name down on the whiteboard, and when we're ready to go, we're going to start calling one team at a time. And I believe we'll have several rigs going. They can test their device on a real rig. After a certain reasonable period, they'll be kicked off, and they can either sign up again, or they can go home and work on it. We see a lot of teams work on it right here at the Tech, making minor modifications, and then coming back to test as many times as they want. Steve?
We do limit the number that sign up for each session, and just with that in mind. So they will be able to go through multiple times. Usually, I don't know, 3-4 times, something like that was probably about the average last year. Depends on how many people show up, because we have a maximum sign up, but not everybody shows up. So.
Sorry about the background noise. That's the exit for Star Wars back into the museum. So someone obviously enjoyed themselves.
And on a personal note, the test trials are the most fun part from my point of view. We get to see the students come in with their first ideas, and they usually don't work, and then they go off and they make a modification, and they come back again. And just to see the enthusiasm in the students as they make slow progress, they increase their measure of success. It's the most rewarding thing for me.
And one thing I'd like just to add, because it comes up occasionally, students ask it, the advisors ask it, you don't have to come to the trials with a complete solution. So it doesn't have to be complete. It doesn't even have to be one solution. You can come with multiple solutions at that point. So if the team has basically been spending the week focusing on a wind capture device and energy harvesting device for the wind, they can come in, test that out, even if they don't necessarily move any water. Or if they have some water transport device, a portion of the device they want to test out, they can bring that in, even if they haven't necessarily figured out how to power it yet. So that's things to keep in mind, is you can bring different portions of the device. That's why we have the trials, to test every little bit out.
Yes, sir.
Do we have to come to test thing? Or I'll try my best to come, but in case of external event.
You do not have to show up to the test trials. It's totally extra on the part of the team. It's highly encouraged. The teams
Sure.
that do the best on the event day are the teams that we've
Sure.
seen over and over again at the trials, but by all means, we realize a lot of people are out of the area. You do not have to come to the trials.
That will not hamper their credits or anything like that, right? I mean,
I'm sorry?
that will not cut their credits
No.
or something
No.
like that.
It's very informal during the trials.
Okay, bro. Thank you.
Benny did point out, or to me just now, if you're coming to the trials, bring a towel or something just to dry off the rig or dry off your parts.
And don't leave wet stools around.
Anything else? I'd like to just emphasize home-built versus store-bought. The team that comes in with the device that's the most home-built will score the highest. So I don't think there's any kit out there for Tech Challenge 2014 to actually buy, and it'll solve the challenge. But here's an example of last year. This rig here is pretty much home-built. They're using basic steel build connect stuff, and they put their own motor on it, and they've got their own platform with some sort of a Canon device which has their own springs. This was totally built by hand using basic components. This is what we want to see. This is going to score the highest for home built. Now here's an example of what I would call store-bought. The same idea to move something from point A to point B. This is a home-built crossbow that's been mounted to the top of a ladder. there's very little home built in this solution here, so this would score very low in my mind for home built, and this device would score very high for home built. Any other questions?
I have a question regarding the teamwork. Are you expecting all members of the team to be knowledgeable about the whole design process, or can they be, one be on the design, the other person on the marketing or documentations? How does that work?
I think we expect every student, since there's no marketing aspect to the tech challenge, I would expect the students to be knowledgeable about how the device works. Within a small group, I would expect everyone to know how it works. I have no problem if one person is the expert in the device, but everyone should know how it works. Any other thoughts?
We're really looking for everyone to have a role, though. One person may be the person that does the diagrams, drawing or something. One person may be the safety officer, one person. So we're really looking that everybody's involved. They don't all have to do everything, but we want to make sure that everybody's involved, and all of them should certainly have a general knowledge of this is our device and this is how it works.
I'd like to ask this simple question here, and that is, what happened in previous events of the Tech Challenge? I have found that from some friends that competed in the Tech Challenge, they said that some of the judges actually pressed some of their teammates like very specific questions that they could not, that specific teammate could not answer, because in a real world environment, you would have several people that will specialize in construction, others that will specialize in video, editing, and other people that will specialize in documentation. And given that one specializes in one field, they may know, a little bit or none of the next field. And what happened was that, my friends, these group of.
That said, though, we don't want to see one person doing all the talking, and sometimes that's what happens. One person tries to do all the talking for the team, and at that point, that's when the judges will try to ask specific questions of specific people, and it's just trying to get engagement from everybody on the team.
If I understand it correctly, you have a three-person team come up to do the presentation. If we have 5 or 6 students that are working on the project, if there's a question that someone who is not in that presentation group could elaborate on, are they allowed to speak, or only the 3 that are up?
No, we ask the entire team to come up and do that. It can be a presentation, but really it's more of an interview with the judges when they get there. And we ask that the entire team is there. And so the teams are anywhere from 2 to 6 people. Everyone should be involved there, not just 3 people, not just part of that. Now we realize that during lots of things happen. There's soccer practice and there's other things, so not everyone from the team may show up. But in those cases, the person is absent. Somebody else should know what that person did or what would be able to answer those, because we can't. That's the case where a judge would be asking and they say, oh, Fred did it, but he's not here today. Well, that's not going to be an acceptable answer.
Everyone should have a basic understanding of what their device does. It's pretty obvious when someone shows up and it's basically, I joined the team last week. That we've seen that a couple times, and it's pretty obvious to see through that. Usually they're pretty honest.
Yes, sir.
For the team structure and team size, what time you guys have cut off, or till at the end people can join or team can join, something like that? Because I'm trying to get 2 more members to see, but I'm not getting commitment. And is it okay, even if they're not committed, they can be a part of this, but at the last end they don't want to come on or on the stage or whatever when they're doing experiment? Is that something acceptable? Or because what other parents say is that, I don't want commitment because it's the last moment, it's just almost like 2 months, so there are a lot of other things going on. So, but yeah, but for a few weeks he can come and then contribute. So, will that acceptable, or it's okay for them because it's friends, so they want all friends to join.
Go ahead, Richard.
So, team members come, team members go. We've had we've had several students over the course of the years who basically were a team of 6, and by the time event day rolls around, it's a team of 1, which isn't a team, and they still come and have a good time and enjoy everything. Same time, we do know we have dedicated team members who wind up falling sick on event day, and they can't come. Now, should a team win an award? Should a given team win an award? My opinion, and I think everyone will probably agree with me, we want to give the award to everyone who contributed to that team substantially. Now, if you have 2 people who were on the team last October, and you haven't seen or heard from them since last October, by the time the event day rolls around, if the team wins an award, I would say give it to the 3 people who were actually at the event day, who actually contributed to the project. And the 2, even though they're good buddies, good friends, who were on the team back in October, I wouldn't give them an award because they had no contribution to the event. So that's why you have the ability to go through and edit the teams on March 31st. It's 12 days out from the event competition, right? The team members know who's on the team and who isn't on the team. That way, should someone turn up sick, have the team say, hey, look, Fred is our good friend. He unfortunately got the flu or whatever lurgy happens to be in April. That'd be my opinion. If anyone disagrees, please chime in. March 31st is the deadline for changing team names and team member names, yeah.
And I guess I would defer to you guys as the adults to determine who you really think is a member of the team.
I mean, we've had occasionally teams show up with a sibling who basically just tagged along. So, siblings must be of age, which means if anyone shows up who is a team member, they must be at least 5th grade. No mascots. They're cute and all, but they get on their feet and can be very dangerous.
Yeah, siblings can watch from the bleachers, just along with the rest of the family. Anything else?
No?
All right, great. Thanks a lot, guys. Appreciate your taking your time. Your students will be coming out probably in another half hour, so you can hang out here or you can check out the museum.